All right, class, we're moving right along with chapter 10. We're going to move into lesson 4, compound events. So, a few vocab words I want to quickly go over. A sample space is a set of all possible outcomes of one or more events. So, it's when you list out all of the possible outcomes. Sometimes we use tables or sometimes we use a tree diagram to represent the sample space of two or more events. And I'll show you what those look like momentarily. The fundamental counting principle, this is something important and something that you guys are going to probably end up loving because it makes your life a lot easier. But it's just another way to find the total number of possible outcomes. Basically, what you have to do is you have to find, this is when we're talking about multiple events. So compound events means there's multiple events, not just one event happening. When there's multiple events happening, you find how many outcomes are there for one event, how many outcomes are there for the other event, and then you end up multiplying them together to get the total number of possible outcomes. And we'll get into that shortly as well. So this is just the actual definition if you want to take a second to read that. And the last thing, a compound event, like I just said, it's when there are two or more events happening. The ratio is the same as a single event for probability. So the ratio of the number of favorable outcomes to the number of possible outcomes. So we still set it up the same way to find the probability, but when we're finding the sample space or using the fundamental counting principle, I'll show you what that looks like. So let's look at an example here. Our first example, you randomly choose a crust and style of pizza. Find the sample space. How many different pizzas are there? So we're going to find the sample space. The sample space, again, it wants you to list every single possibility, all of the different outcomes. So if we look over here to the left, those are your crust options. It can either be thin or stuffed. And then there's 4 styles of pizza you can choose: Hawaiian, Mexican, pepperoni, or veggie. So when we're creating the sample space, I'm going to show you what a tree diagram looks like. What you're going to do is you're going to list your options. So here, our crust options, it can either be thin crust or stuffed crust. Now, from here, you can have different styles. So you can have a thin crust that is Hawaiian style. You can have a thin crust that is Mexican style. There's 4 different styles. So what you're going to do is you're going to branch off of that crust and list those 4 different styles. So you would take the time, I'm just going to abbreviate for time's sake, and you would write those down. And then the same, you would then go to the other side of the crust. So there's a stuffed crust, but the stuffed crust can also be these 4 options. It can be Hawaiian, Mexican, pepperoni, or veggie. So now for your outcomes, when you list your outcomes, this is how many different outcomes did you have here. So we had our first outcome was a thin Hawaiian pizza. So I would list, okay, it could be thin Hawaiian. My second option was a thin crust Mexican style pizza. My third option was a thin crust pepperoni. My fourth option was a thin crust veggie. Hopefully you're still with me. And then we still have these other options. Well, what if there's a stuffed crust? So our 5th option was stuffed Hawaiian. My 6th option was stuffed Mexican. That's a 6. My 7th option, I'm going to come up here, was stuffed pepperoni. And my 8th option was a stuffed veggie. So this is your entire sample space, listing out all of the possible outcomes. Now they asked you how many different pizzas are possible. There are 8 possible pizzas, and we just listed them all out. Let's keep moving along. Find the total number of possible outcomes of rolling a number cube and flipping a coin. So guys, think about it. When you roll a number cube, when you have that event happening, what are all of your different outcomes? And I'm going to set up a table. This is another method, another way of doing it. Let's do it as a table. When you're doing a table, you want to list out all of your outcomes for each event. So rolling a number cube, I could roll a 1, 2, 3, 4, 5, or a 6. When I flip a coin, I could flip either heads or tails. So notice, horizontally, you want to list all of your outcomes for your one event, and then vertically, you want to list your outcomes of the other event. And now we're going to look at all those different combinations. So I'm just going to fill in this table. So here I could roll a 1 and flip heads. Here I could roll a 2, flip heads, and so on. These are listing all of my possible outcomes of rolling the number cube and then flipping heads. Go to the next row, and I'm just going to do it with, now I have tails. So I could roll a 2 and flip tails. I could roll a 3 and flip tails, 4 tails. Now this is giving me all my possible outcomes. So now you're just going to count it up. There's 1, 2, 4, 6, 8, 10. There are 12 possible outcomes. So what's the total number of possible outcomes? There are 12 when you flip a coin and roll a number cube. Now, let me show you real quick. Another method is we could use the fundamental counting principle. What that means is you're going to think, rolling a number cube, how many possible outcomes are there for rolling a number cube? Well, we could roll a 1, 2, 3, 4, 5, or a 6, so there's 6 ways. How many outcomes are there for flipping a coin? You can only flip heads or tails, so there's only 2. The fundamental counting principle says to state how many outcomes of each there are, which we did, and then multiply them together. What is 6 times 2? 12. So how many total number of outcomes are there for these 2 events happening? 12 ways, which didn't we just say that when we showed it through the table? So either method works, using a table or using the fundamental counting principle. Let's use that fundamental counting principle again. Let's just, actually, I want you to find the probability of rolling a number greater than 4 and flipping tails. So maybe you want to look at your table. I have to roll a number greater than 4, so it has to be a 5 or a 6, and I want to flip tails. So this is a 5 or a 6 tails. So that can only happen 2 ways out of how many total ways were there? 12. So the probability of rolling a number greater than 4 and flipping tails is 1/6. All right, we're going to stop right there.